Welcome to Chapter 5, Elasticity and its Application. This is Module 1, Introduction to Elasticity. In Segment 1, we will cover the importance of elasticity to analyze changing market conditions. What will you learn in this chapter? You will learn how important it is to measure how sensitive demand and supply are responding to price changes. You will learn why gas prices are way more volatile than the prices of other goods, for example, the prices for apples. And we will introduce the definition of price elasticity, which measures the sensitivity of demand or supply. Most of us gave up on asking why gas prices are so high. But were you ever wondering why gas prices are so volatile? While most prices fluctuate in a few percent range, it is not uncommon for gas prices to increase or decrease by 30 or 40% just in a few weeks. Before we turn our attention to the gas market, let us first review what you learned in the previous chapter about the Apple market, so we can compare the Apple market later to the gas market. In the last chapter, we analyzed the effect of a bad harvest on the Apple market. In the initial equilibrium, the equilibrium price was P0, and this resulted in an equilibrium quantity of Q0. Now we have to figure out how the bad harvest would influence demand and supply. We start with the demand curve. A bad harvest is not a determinant of demand. Therefore, the demand curve will not shift. But a bad harvest is a determinant of supply. It is a determinant other than the price. Therefore, it is not a movement along the curve will shift. Then we had to analyze in which direction the supply curve would shift. A bad harvest leads to less supply, therefore the supply curve shifts to the left towards smaller quantities. After the supply curve shifted to the left, the old supply curve is not valid anymore. And the intersection point between the demand curve and the old supply curve is not relevant anymore. We have to find the new intersection point, which represents the new equilibrium, find out which price goes with it by going horizontally to the price axis, and we label this price as P1. Then we go straight down to the quantity axis to find out which quantity goes with the new intersection point or with the new equilibrium. And we find the quantity Q1. To summarize the result, the bad harvest resulted in a small increase of price, which created a fairly big decrease in quantity. Now let us take a look at the gas market. Why are prices for gas more volatile than prices for other goods? For example, why are they more volatile than the prices for apples? Gas markets don't have bad harvests, but in 2005 another disaster influenced the market prices for gas. When Hurricane Katrina destroyed oil platforms in the Gulf region, the price for gas skyrocketed. How can we explain this? We again start our arguments with the initial equilibrium. We find the initial equilibrium at the intersection point between supply and demand curve. From this equilibrium point we go to the left to find the price, the initial price, which is here labeled as P0. We go straight down from the equilibrium point to find the quantity, the equilibrium quantity, which is labeled here as Q0. How would the destroyed oil platforms influence the gas market? We first ask the question, are the destroyed oil platforms a determinant of demand? No, they are not. Therefore, the demand curve will not shift. Destroyed oil platforms are actually a determinant of supply, and they are a determinant of supply other than the price. This means the supply curve will shift. Finally, we have to find out in which direction it will shift. If platforms are destroyed, there will be less oil supply, therefore there will be less gas supply, and the supply curve will shift to the left towards smaller quantities. After the supply curve shifted, the original supply curve is not valid anymore. The same is true for the original equilibrium. The new equilibrium is where the new supply curve intersects with the demand curve. From there we go horizontally to the left to find the equilibrium price. We label this price with P1. We go straight down from the equilibrium to find the new quantity. We label the new equilibrium quantity with Q1, and we now can summarize the result. The destroyed oil platforms in the Gulf region resulted in a large increase of price, which created a fairly small decrease in quantity. Let us compare the two markets. First, the apple market. A shortfall of supply because of the bad harvest led to a small price increase. In the gas market, a shortfall of supply due to destroyed oil platforms led to a high price increase. And compare the shifts of the supply curve, they are exactly the same. So where is the difference which triggered these different price reactions? It is actually the demand curve. In the apple market we have a flat demand curve, and in the gas market we have a steep demand curve. To analyze the economic meaning of a flat and of a steep demand curve, we omitted the supply curves in both diagrams to solely focus on the demand curves. What happened in the apple market? After the shortage in supply, the demanded quantity had to go down too to guarantee a new equilibrium. When the price increased, this triggered a large change in demanded quantity. A small price change resulted in a large change in quantity because the demand curve reacted very price sensitive. The situation was similar in the gas market. There was a shortage in supply and prices had to increase to reduce the demanded quantity. What can we see? Even a large increase in price resulted only in a small decrease in demanded quantity. Why is that? Because demanded quantities reacted very price insensitive to changes in the price. Therefore, it took a bigger price change to result in an even smaller change in quantity demanded. You see how important it is to find out if demand reacts price sensitive or if it reacts, like in the gas market, price insensitive. For this reason, it is extremely important to be able to measure the price sensitivity of demand. Another word for price sensitivity of demand, and that's the economic word, is price elasticity of demand. And in the next slide we will see how we can measure price elasticity of demand. Economists measure the price sensitivity of demand or the price sensitivity of supply with the concept of elasticity. Economists define price elasticity as follows. Price elasticity measures the percentage change of quantity demanded when the price changes by 1%. Or for price elasticity of supply, price elasticity measures the percentage change of quantity supplied when the price changes by 1%. So the price change is standardized to 1%, and then we measure the percentage change in demanded or supplied quantity. And whatever the result is called price elasticity. To calculate price elasticity in general, you have to take the percentage change of quantity and divide it by the percentage change of price. Here is an example how to calculate price elasticity of demand. Let us assume the price increased by 7% and the quantity demanded decreased by minus 21%. To calculate price elasticity, we take the percentage change of quantity and divide it by the percentage change of price. So we divide minus 21%, this was a percentage decrease in quantity, and divide it by 7%, which was a percentage increase in price. The result is minus 3. How can we interpret the result? A price elasticity of -3 means that the quantity demanded decreased 3 times more then the price increased. Is this compatible with the definition of price elasticity, which suggests in this case that a price increase of 1% leads to a decrease of demanded quantity of 3%? Yes, it is. To understand this, we have to take a closer look at the fraction. In general, the line of any fraction can be interpreted as the word per. The fraction then reads as minus 21% change of quantity demanded per 7% change of price. If we divide the percentage quantity change by the percentage price change of 7, and if we want to apply this to the fraction, algebra rules require that we divide the numerator as well as the denominator by 7. This leads to minus 3% over 1%. The fraction now reads as minus 3% change of quantity per 1% change of price. This is exactly compatible with the definition of price elasticity. What did you learn in this segment? You learned why it is important to measure price elasticity. Price elasticity measures the sensitivity to respond to changes in price. You learned the definition of price elasticity. Percentage change of quantity over percentage change of price. And you learned why price elasticity measures the percentage quantity change when the price changes by 1%.